So in this video, we're going to be looking at writing balanced ionic equations. We've got an example over here with sulfuric acid reacting with aluminium. Now, in order to write a balanced ionic equation, we need to be able to do this in a series of steps. Now, of course, in some cases, you can just memorize the equations, but in this one, you have to be able to work it out. So starting off, we would look at our aqueous compounds and we would show them as being dissociated, and anything that's not going to be in solution, that's not going to be aqueous, like our solids, liquids and gases, we just leave them as they are. We don't dissociate them. Now, once that's done, we can cross out any spectator ions, and our spectator ions are those that are not going to change from reactants to products, including physical state as well. Now, once that's done, we can simplify our equation down. Let's say if we're dealing with any molar ratios like 2 to 4 to 4 to 2, we can simplify that down to 1 to 2 to 2 to 1. And of course, that's just us trying to get the most simplified formula, the most simplified equation that we can as possible. So looking at this example, then here's how I would go about it. I've got 3 times 2 lots of H2, so that's going to dissociate to form H+. So I actually end up with 3 times 2, that's 6 lots of H+ to start off, and then that's going to react with, of course, our sulfate ions. We're going to have 3 lots of sulfate ions as well, and then we're going to have, after that, aluminium. We've got 2 lots of aluminium there, and then we're going to end up with forming, of course, aluminium sulfate. That's going to be 2 lots of aluminium 3+, and then we're going to end up with, of course, our sulfate ions. We're going to end up with 3 lots of sulfate ions over there as well. I'm going to finish this off with 3 lots of H2 gas. Now I'm going to look at my spectator ions. Have I got anything on the left versus right? Yes, I do. I've got 3 lots of sulfate ions there, 3 lots of sulfate ions there as well. So my overall equation, it should look something like this, where I've got 6 lots of aqueous H+, and that's going to be, of course, AQ. That's going to go ahead and react with 2 lots of solid aluminium. So I'm going to end up with S over there, and that's going to give me 2 lots of aluminium, and that's going to be, of course, 3+, but don't forget that's going to be aqueous too. And then I'm going to end up with 3 lots of hydrogen gas as well. I'm going to put a G there as well. So that's our first 2 steps done. What about the third step, finding the simplest ionic equation? Yes, that's going to be the simplest one because we've got a 6 to 2 to 2 to 3 ratio. We can't actually get any smaller numbers compared to that. That's going to be our simplest whole number ratio, and there's that one done. Now, moving on, I want you to have a go at the following. I want you to pause the video, have a go at these, and then resume once you're ready to go over the answers. So you're looking at these questions then. We've got the first one, which is sulfuric acid, sodium carbonate, sodium sulfate, water, and then carbon dioxide. The things that will dissociate in this case is going to be, of course, sodium sulfate, sodium carbonate, and then sulfuric acid as well. So what I'm going to end up with is as follows. I'm going to end up with 2 lots of H+, and that's going to be, of course, aqueous. I'm going to end up with, after that, reacting it with sulfate, which, of course, is going to be aqueous as well. And then I'm also going to end up with carbonate and sodium ions. So I end up with 2 lots of sodium ions, which is going to be aqueous. And then, of course, my carbonate ion as well, which is also going to be aqueous. Now, what am I actually going to end up with as products? Well, 2 lots of sodium ions as well. So that's going to be aqueous too. And then I end up with sulfate ions, which is aqueous as well. And then I also end up with my water, which is a liquid. And then I end up with carbon dioxide, which is going to be a gas. Now, what can I cancel on both sides? Well, from the looks of it, it looks like the 2 lots of sodium ions here, the sulfate ions over here as well. And that leaves me with the following, where I've got 2 lots of H+, that's aqueous. And then I also end up with carbonate ions, which is going to be CO3 2-. And I end up making from that my water and carbon dioxide. And there's that one done there. Now, looking at this, of course, we know it's going to balance. We can't actually end up with anything simpler than that. So we know, of course, this is our simplest whole number ratio. Looking at the next one, similar type of thing. I've got 2 lots of HCl, and then I've also got, of course, calcium chloride. They're both going to be aqueous. So in that case, I end up with 2 lots of H+, and that's going to be AQ as well. And then I end up with 2 lots of chloride too, which is also going to be aqueous. And then we end up with 1 lot of calcium oxide, which is a solid that can't be dissociated, of course. And then we end up making, of course, our calcium ion, which is going to be calcium 2+, and that's going to be aqueous, plus 2 lots of chloride ions, which is also going to be aqueous. And then we also end up with, of course, water over there, which is going to be a liquid. Now what can we cancel? The 2 lots of chloride ions for definite, and then of course we would also just be leaving it as that, to be honest. So we end up with overall it's going to be 2 lots of H plus, that's going to be aqueous, and that's going to react with calcium oxide, which is going to be a solid, and then we end up producing calcium 2 plus ions from that, which is going to be aqueous too. And then we also end up with water, which is going to be a liquid. We can't really simplify this down any further. And there's that one done there as well. So yeah, look at the next one. We've got nitric acid, that's going to be of course aqueous, sodium hydroxide, that's aqueous, and then sodium nitrate as well. So this one, we're dealing with quite a lot of aqueous species, and then we end up producing water, which is a liquid. So over here, I'm going to end up with H plus, and that's going to be aqueous. And of course we also end up with nitrate ions, which is also going to be aqueous, and then sodium ions too. And then we also end up with hydroxide ions as well. Now of course we're going to end up producing from that, it's going to be our sodium ions again. So it's getting quite repetitive now, it's quite a long process, and of course we do it this way to avoid making any silly mistakes. Our nitrate ions is over here too, and then we end up making water as well. Now in terms of what we can cancel, we can end up cancelling the actual sodium ions over here with those there, the nitrate ions over here with those there, and overall we actually end up with the equation for neutralization. So I end up with H plus, which is going to be of course aqueous, that reacts with hydroxide ions, which is going to be aqueous as well, and then we end up producing overall our water, which of course is going to be a liquid as well. And there's our simplified equation done there.